How's it going, everybody? I wanted to put together a video that's a R refresher for some of you and an overview for others. The Most of you said that you were intermediate R users, so a lot of this may not apply, and you can probably just scroll through the script. But if you do want a little bit more of a refresher, I'm going to try to get through this as quickly as possible. What I have today is it's mostly the drill script from the first drill. If you were in GLM with myself and Patrick and Bill last year, so this is the first drill script with a few extra things added at the end, and then a couple small edits in the middle, but by and large it's the same script. And so, feel free to go through it in its entirety on your own. I'm going to just skip through parts today and kind of fly by the seat of my pants and just try to hit up some main highlights. One thing I want to point out is that down here you'll see, as I'm typing, you'll see the keys pop up. I just did that so that you can see if I'm using keyboard shortcuts. You can see what I'm using. If you're not a Mac user, on Macs we have 3 buttons: Command, Control, and Option. So if I'm using, Control A, it'll be the caret symbol. Option A will be this weird looking symbol, and then Command A will be this. So if you're a Windows user, you'll just have to look up what the equivalents of those are. And there should be a keyboard shortcuts option, or down later in the script there's a link to some cheat sheets, and on this cheat sheet it has the full a bunch of the keyboard shortcuts both for Windows and Mac. So as I do things, you can reference that and figure out your own keyboard shortcuts, because they're definitely useful to learn. So as far as running these scripts, if you're just now setting up R and you haven't installed packages before, you'll just have to delete those hashtags and run this line for installing Tidyverse and PSYC, which are the 2 libraries that are used in this script. Alternatively, you can just go up and come to install packages and search for Tidyverse and click install, and it'll install it that way. So we're going to load the Tidyverse and PSYC libraries today. Now, before I do, I want to point out basically what this little paragraph is talking about is that if we're trying to use a function from the PSYC library, like describe, and let's just say I have some numbers in here. It's going to tell me that could not find the describe function because describe is in this PSYC library that I haven't loaded. Instead, I could just explicitly call it and it will run. However, once I load the library, now I don't need to put PSYC in front of it. I still do use that notation sometimes just to let you know where things are coming from. But also I'll use these explicit calls if I'm running a function, just one function from a library, and I'm only running it once or whatever. Then I don't want to load the entire library and have it loaded throughout the script. I'll just call it that one instance where I actually need it. Part of the reason for that is when you do load libraries, you have to be sure to pay attention to what these messages down here will tell you, because here it's got some conflicts and it'll tell you when things are being masked. And what that means is, for instance, dplyr filter is masking stats filter. Stats, which is just base R, has a function called filter, but so does dplyr, which is one of the, when we load Tidyverse, it loads all of these packages. One of them is dplyr, and we use this a lot. In fact, we use dplyr's filter a lot. So if you just type in filter into R, it's going to assume that you're talking about dplyr's filter, not stats filter, and that's because this is masking this other one, which basically means like it has the default position. So if something is being masked and you need to call the one that is being masked, then you would have to explicitly call stats filter or whatever, like that. And so that's part of why I don't automatically load every library that I touch. If it is just one function or whatever, then I'll use these explicit calls to have less chance of running into conflicts with things being masked. For the appearance, if you're just setting up RStudio, or if not, just as a reminder, the way I have it set up is with my script up here. I've got my console, which is the output down here, my environment down in this bottom corner, and then over here is where plots and files will be. If you want to change that, you can come up to your global options and go to your pane layout, and you can switch this around if you wanted your output over here for whatever reason, or if you want your plots down here instead of up here in this one. Whatever the case may be. As far as the appearance, there are all these different themes. I personally prefer, dark themes with a lot of contrast. So Merbivore is my favorite. But you'll notice that like the functions in this theme are, orange. If your functions aren't showing up in a different color, it can be really hard to read code. And what you need to do is come over here to code and then go to display, and down at the bottom there's an R function, or highlight R function calls. Check that, click apply, and once you apply it, or if not when you apply it, then when you restart R, then in your code all the functions will change to that other color. Just general notes: R is case sensitive, spaces aren't red, they're just there for readability. Brackets got to come in pairs, and copy and paste is your friend. As far as these pound signs, just a reminder that R will ignore everything in a line that follows one of these. So as you're commenting throughout scripts, let's say you're wanting to remind yourself why you're loading psych, and that's because we're gonna be using describe, and so R won't read this because it follows that pound sign. If you have 4 consecutive pound signs at the end of a line, it will give you this little drop down arrow, which can be nice for formatting, say on assignments, and being able to collapse your questions. There's no limit to how long out to the side R will go, so you have to be mindful, because you don't want to be having to scroll over. And so let me refix this so that I can give you this example. So there's a keyboard shortcut called reflow. On Macs, it's Command Shift and slash. For Windows, it's Control Shift and slash. And what it will do is, if you have long lines that run off the edge of the screen, long comments, it will break them down and consolidate them into shorter chunks on several lines. And here I say like that it's mindful of the formatting, and what I mean is that you see here that we have one hashtag that this isn't indented. This is indented a couple times and has 2 hashtags. This is indented once with 2 hashtags. This is indented like 4 times with 4 hashtags. And so here, if I reflow this comment, it keeps it indented that far with 2 hashtags. Here again, you see it's indented that much with 2 hashtags. When you reflow that, it's mindful of that, and it keeps that same thing. Here we've got 4, and when you reflow it, it's gonna be mindful of that. So that's what I mean when I say it's mindful of how you formatted your hashtags. But so that's just a nice little keyboard shortcut as you're typing out your answers, and just want to break it down to keep it all in one screen. You can just use that reflow keyboard shortcut. Not really going to get into data types and structures. Really, the only thing I want to mention is numeric and double are one and the same. Sometimes you'll see it referred to as numeric, and sometimes it'll say double. And it's the same thing. That's a vestige of that used to be meaningful, that things were called doubles, but now it just doesn't matter. If it's a double, then that just means that it's a numeric variable, or and then down here, a factor. I say here that it's nominally different. It is different. The reason I said nominally different is because if you have characters, but then you put that into, say, a linear regression, R will automatically convert that into a factor. There is more to it, and we can get into some of that nuance as we go, but I'm not too worried about it now. And then the different types of structures, so whether it's a matrix, a vector, or a matrix, or a list, or a data frame, or a tibble. One thing I do want to point out is, what does tibble mean? And tibble is just a data frame, but it's a tidyverse data frame. And there are a few nice features about tibbles that we'll get into as we go, but I just wanted to point out that you can use the words data frame and tibble more or less interchangeably. And then also, this atomic vector is often just referred to as a vector. So for here, I'm not going to waste the time going through that. You can run through it yourself. One thing I did want to point out, though, is always use spaces around your infix operators, like plus, minus, and your inequality symbols, just because it makes it more readable. So this line is more readable than this line, and this line is easier to read than this one. If you're trying to use inequalities to return true and false statements, you can do that. Less than or equal to is written with the less than sign followed by equal. Greater than or equal to is written like this. The ampersand is used for and. The or is this vertical bar. That's the shift / will give you that vertical bar. If you're trying to say something is equal to something else, you don't just use one equal sign. You got to use two there. So 5 is not equal to 2, 5 is equal to 5, and the exclamation point is the negation operator. So this reads 5 is not equal to 2, which is true. You store things you can with this assignment operator, the arrow pointing to the left or right. I'd always use the left pointing operator, partly because there's a keyboard shortcut for it. That's option minus for Windows, and I think it's alt minus for alt minus for Windows, and option minus for Macs. It'll put in that left pointing arrow. But also, I like always having like my objects on this side, so that as I'm scrolling through, if I, instead of doing it this way, if it was 5 with the arrow pointing the other way, these two statements right here are identical. But especially as we get going further, when it may be that we have a long line of code that then comes out over here, and now we have some object out to the side. It's just harder to find it, whereas over here, if the objects that you're creating are always right on the margin, it just makes it a little bit easier to read. So I always suggest using the left pointing arrow. Technically, you can use a single equal sign as an assignment operator, but you will never ever do that. Like, I will never not correct you if you do that, because that does become problematic later, and it can be confusing, but you'll see people doing that, but I will not be happy with you. So don't do this. Instead, just use that assignment operator. So as far as running things, definitely figure out your keyboard shortcuts for running lines. If I'm on a line and I hit Command Enter, it's going to run that line and it's going to store hello world. as a phrase. So now if I, just run phrase, it's going to say hello world. If I highlight a section of a line and run it, then instead of running the whole line, it'll just run that the portion that's highlighted. If we have, say a vector of numbers that we store as D, and now we can save that as an integer. And here we save that as integer E and as character F. And so now if we do E plus 5, it will add 5 to each element in that vector. Because for F, even though it looks like it's still 3, 7, 2, 12, 9, it's in quotation marks, it's a character, so if we try to add 5 to that, it's not going to, because it's saying, hey, you can't add numbers to characters. Moving along, for sequences and indexing, you can use this colon in between things to indicate a sequence between. So 1:10 is a sequence from 1 to 10. 4:9 is that sequence from 4 to 9. We'll come back to that sidebar in a second. If you, I guess we can go ahead and say this. So if you find yourself needing help, add a question mark before a function, and it'll pull up the help. If the function is in a loaded library, if you try a single question mark and your help doesn't pull up over here, then do a double question mark, and that will search all help, not just the loaded libraries. But here you can see that the arguments for the sequence function are from, to, by, etc. And so you can specify a sequence from 4 to 10 by 0.5, and if we run that line, it will give us that sequence from 4 to 10 by halves. Note, whenever you hover over a function, or if you look over here in the help file, it'll show you the default order to enter things in. So here where we have from equals 4, to equals 10, by equals 0.5, because from, to, and by are the default orders of sequence, we can leave off those explicit calls, and we could say from 4 to 6 to 0.5. But if we wanted to do those out of order, we could switch this around and have 210 from 4 by 0.5, and it'll still give us the same thing as long as we explicitly tell it what's what. If you don't have it in the default order, you do have to explicitly enter from 4 to 6 by 0.5. Then, this is just saying that if we wanted to start by zeros and go by this weird number and go for 30 iterations, you can use your length out thing. For indexing, so if you're trying to subset or index things, you can use these square brackets. So up here I guess I should create. So I'm going to store this vector of animals as an object called animals, and just as a reminder, this C is the concatenate function, which is anything that goes inside that is a way of telling R, like, hey, here's a bunch of different things, but it's actually just like one vector of things. And so now when we look at animals, we see that it is a character vector that has 5 elements. So coming back down here, if I want to index that vector, if I say animals then in brackets 1, it will give me the first of those animals. If I say 2 through 4, it'll give me those. Or I can concatenate and say I want the first, fourth, and fifth. And that's for that vector, which is unidimensional. But like if you're looking at a data frame which has 2 dimensions, then you it works the same way, but it's row comma column. So df bracket 1 comma 3 will select the first row, third column, whatever is in that first row of the third column. If you do 3 comma 1, that would be the third row, first column. If you leave something blank, that's how you tell R all of the things. So if you just do from your data frame 1 comma space, then that tells it the first row, but I want all of the columns, so it will give you the entire first row. Or space comma 3 will give you all of the rows in the third column. Naming conventions, you can read over this in more depth, but the thing that I just really want to hit is that your name should be meaningful and concise, and you need to have a convention. There's a lot of reasons for it. Some people like snake case, where typically snake case is uses underscore, and then people will call it dot case when you use periods. I personally prefer using lowercase everything and just separating by periods. Some people like underscores. I don't like that because it takes 2 keys to type an underscore, and so it's just more efficient typing wise just to hit a period instead. Some people like camel case, where it would be names like this, and that's just not my personal preference. But as far as the names themselves, you'll be typing these names a lot, and so if you name log transformed reverse scored anxiety item 4, and you're having to type that over and over, that's gonna be really messy. But objects can't begin with digits. Only characters can't have spaces or special characters, except in the case of Tibbles, but we'll get to that down below. For the purposes of our class this semester, my personal naming conventions won't always be applied, because both it's not my data file, so a lot of the variables already have names, plus I'm somewhat trying to stay consistent with the way Anna's done it in the past, so that the people who are working on SPSS, they're using the same variable names and things like that. So just know that my personal opinion of best practices as far as naming conventions aren't being strictly applied this semester, but we can talk about that more throughout the semester. But one of the reasons that it's nice to use or have these naming conventions, for instance, one of the things that we'll talk about as my convention is I like to have, for all factors, I like to have a factorized and a numeric version, and so I would call them var.f and var.n, where var.f is the factor version and var.n is the numeric version, and I have explicitly 2 separate versions of that variable, and I'll do this across all of them. And one of the reasons for that is when you have this convention, I use var.mc means the mean centered version, log.var is the log transformed version, and you can do a lot of things systematically automatically when you use these systematic naming conventions. For instance, if I wanted to pull all of my numeric variables to do some sort of run correlation tables or whatever, I could easily select all variables that end in .n and do things with it and stuff like that. So having those consistent naming conventions can make it easier to iteratively do things and loop across things and be able to make R do a lot of work for you instead of you having to sit and manually type out a lot of things. But again, we will talk more about that as the semester goes on. So for using R projects, this is something that's really, really important. So if I look at my working directory, is this folder, Unit 1, Data Cleaning, Missing Values Estimation. That's because this is my folder structure. The reason that is my working directory is because that's the folder that had my R project in it that I opened. Now, I should be posting in the class box folder a pre-filled folder structure for you that has different unit things, and in each unit folder is already an R project. And so all you'll have to do is whenever we post scripts and data, you'll just have to download it and drag and drop it into its appropriate unit folder, and then from there open up that R project, and you'll be good to go. So what these R projects are doing is, for one, it automatically sets your working directory to whatever folder the R project file is in, the rproj file. And so the reason that that's nice is because then also when you have your data in the same file, then you are able to just call that file by name and not have to enter in, a long file path. Also, whenever you export figures and tables and things like that, it's going to automatically export to your working directory. So instead of just having files being saved all over your computer, it keeps everything nice and clean. It does a lot of other stuff as far as, kind of you can save your environment, and it'll save your history and all that sort of stuff. But the most important thing that like I really want to drive here is do not change the file names, and do not do things with manual paths, because then whenever you send me your script and saying like, hey, I need some help, the script isn't working, and I go to load it, and you've changed, assignment 1 data.csv, and you've changed the name to just 1.csv, when I go run your script, it's going to tell me this file doesn't exist because you changed the data file's name, and it's not a data file that exists on my computer. Similarly, if you, instead of using your working directory, if your working directory is, whoever you are, and you set this whole big long thing, then when I go to run your script, again, it's not going to work for me because I don't have that file path. So the only way to get these things to all work cohesively is to be using the working directory the way it's supposed to be used, which R projects makes that a lot easier. So in short, when you again, you'll have a folder with an rproj file. When you open that, it'll open up and it'll look just like this, and it'll have your thing up here, and this over here is where you can switch your projects and whatnot. And then you'll just put the data file and scripts directly into that without changing their names, and then you'll be all the scripts will run on everybody's computers. So I'll let you read more in depth about the other stuff about R. Not going to really worry too much about this section here on reading in data. I will mention that at least here at the start of the semester, we'll be reading in SPSS files, and that's because that's what we have to work with. I'm scrambling, trying to get ahead of the curve here and getting all of these units converted over into R, and figure out how we can cover it in a way that's going to make sense for everybody. And so, because this has always been taught in SPSS, those are the files that Anna has. What I'm hoping is that if I can get far enough ahead, what I can do is clean up data files or prepare them as CSVs, which is far more normative. Like really the only time that you deal with SPSS files is when you're collaborating with a project with somebody else who's using SPSS, because otherwise, you run your experiment, chances are it's going to export it in a CSV or a text file or a DAT file, something like that. But for now, we're going to be dealing with SPSS files, and we'll So we'll deal more with reading in your data files when that time comes. Here, just saving this empty cars data set as a data frame called cars to look at a few things. We can see our structure of that data set. But the way that this truncates like this, I don't like, so I prefer to use the function glimpse, which basically does the same thing. We can see we have 32 observations of 11 variables in this data set. And here are all our variables. They're all that DBL. They're all numeric. And if you want to check out, the head of it, you can specify like 15 rows in the head. Blah blah blah. So this is the important part: is these dplyr verbs. Dplyr is the what we're using in the tidyverse for data wrangling, meaning any sort of moving data around, selecting, transforming, doing things with. And so these are the primary functions that we're going to be using: is filter, select, mutate, summarize, and group by. Filter does exactly what it sounds like. It will filter your data to only select or to only include certain cases. Select will pick the variables. So in other words, if you want to only select certain columns, you'll use select. Mutate creates new variables from existing variables. Summarize is used for summaries, and then group by is how you can do everything by groups. So all of these verbs work similarly. The first argument is the data frame, and then the second argument will tell it what to do with that data frame, and the result is a new data frame. So in other words, if we run looking at cars here, if we run filter cars, we want to filter and only see where miles per gallon is greater than 20. So now we have all of our cars that get more than 20 miles per gallon. With filter, the output of it is just are the cases where the logical test in the filter are true. If you have multiple, you just separate them by a comma. So if we want only the cars where the AM, which is the automatic transmission, equals 0 and miles per gallon is greater than 20, there's only 4 cars that meet that criteria. For select, if we only want to select cylinders, horsepower, and miles per gallon, we tell it select from the cars data frame those 3 variables, and it will select those. Now note that whenever I just run that chunk, it doesn't save. It doesn't store it as an object, but if we use this assignment operator to store it as a variable called whatever, it's now giving me a subset data frame where I have just those 3 columns. For summarize, we could say summarize from the cars data frame. That first argument's always your data frame. And let's create variables called mean MPG. That is the mean MPG. And create another variable called SD, another variable called min, etc., etc. And when we run that, we can see that that's exactly what it outputs. Now, you could leave off the specific names of things and just say, and all that's going to do is it's still going to give you the mean, but it's not going to give it a name. It's just going to call it by whatever the function's name is. So you can also combine all of these things with group by. So in this case, let's say that it's not very helpful, and what I mean here by that's not helpful is it's not helpful to see what's the mean miles per gallon for all of the cars. Perhaps we want to group it by the number of cylinders in the car. So we tell it to summarize. We're going to group by, and we're going to group the car's data frame by the number of cylinders, and then run the same thing. And now we see that the mean miles per gallon for 4 cylinders, for 6 cylinders, and for 8 cylinders, etc. But PSYC describe is a much easier way of getting the descriptives at a glance, especially if like you're not worried about the order that they're presented or anything. It's going to give you all of these basic statistics. So I use that a lot of times, and I really only use summarize when there are only specific stats that I'm trying to pull, and especially if I'm then going to push it forward into some other function. So then the next one is mutate. This is one that we use a lot. So if we want to create a variable called WT ratio, that is the ratio of the car's weight to their quarter mile time, we just tell it mutate the again, data frame is your first argument, cars, and we're going to tell it WT ratio equals weight divided by QSEC. And when we run that, we can see we now have this new variable out here. But that doesn't, like if we go back and look at just cars, we see that it didn't store it. In order to store it, you have to run that same mutate, but you have to use the assignment operator and assign it over itself. And so once we run that line, now when we look at cars, it does have this WT ratio. It doesn't have to just be arithmetic. You can use mutate to apply any function. So if we want to change gear over into a factor, now when we look at gear down here, we can see that gear is now labeled as a factor. We could use an if-else statement to see if miles per gallon is over 30, and it will create this variable called efficient. And then the way that if-else functions work is you give it a logical test, and then the output if the test is true, and the output if the test is false. So in this case, we're saying this new variable called efficient. If miles per gallon is greater than 30, output yes and make efficient yes. If it is not greater than 30, then make efficient no, and there's our new variable. Quick notes for writing tables. Let's say we wanted to take this table and make it into a CSV to copy and paste and format and blah 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 over in Excel. You can use write underscore CSV, and you just put in whatever. In this case, I want to put in that descriptives, and then I'll give it a file name, and I'll say file equals desctable.csv, and if I run that line, it will export a CSV called desctable, and it will put it in my working directory. So to put it right here in this unit 1 folder. na.rm equals true. One thing that is pretty much the bane of every data scientist's existence is usually missing data. And things can get wonky sometimes when you're missing data. So here I'm just going to put in a thing of that's missing here on the third row of the first column. So for this MPG. So now if I say the mean of cars, it's going to tell me NA because I have an NA value. And so you have to do something with that NA. In this case, you have to tell it NA remove equals true. And now when you run that, it's going to be 20. Now, it's not always na.rm equals true is the way that you can remove missing data and handle it. Some functions, depending on the function itself, you have to handle the missing data on the front end of the function. In other words, like filter out the missing stuff and then put it into the function. It varies from function to function. The point is that you do have to be aware of where you're missing data and how you're going to have to handle that missing data. So here I have I'm just using a function called sample where I give it, in this case, a list or a concatenated vector of just male and female, and I tell it to sample male and female 100 times with replacement, and stored as an object called sex example. You'll notice that I have this wrapped in an extra set of parentheses, and all that does is make it to where, like if I run this line down here, which is the exact same but just changing, the names, it's not going to show me the output because I'm storing it as an object. But when things are wrapped in parentheses, it will store it as that object, but also give you an output of what that object is. But I just wanted to point out that the table function will give you quick counts of things. And if you have, now I have this set up as a data frame with both of them. And so if you run table across that, it will kind of give you this cross tab, at least as far as like the counts of things. Last little bit here. Here I just put in a couple links to some different cheat sheets. Pipe operators. This is something that may be new to you, especially if you weren't in our class last year. So this percent greater than percent sign is called a pipe. What a pipe does is it takes whatever is on the left-hand side of it and it passes it through into the right-hand side of it. And it's useful for chaining together, several different things. The keyboard shortcut for inserting pipes is Command-Shift-M on Macs and Command-Shift-N on Windows. I have mine set up for just Command-P. But that's not the default behavior. So if you see like me hitting Command P and you're wondering like, well, why is mine not putting in the pipe? And that's why, because the default is that Command Shift N or Control Shift M. So going back to what we did before, the only difference is that now we take our car's data frame and we use this pipe, and it will take this left-hand side and push it through into this right-hand side. So we still filter miles per gallon is less than 20. So when I talk about being able to chain things together, here in this case we start with cars. Here's the full data set. And then if we run these first two lines, cars is being piped into this filter where automatic transmission is less than 0 and miles per gallon is less than 20. And then we'll group that by cylinder and then run it through our summary. So in other words, we have these 4 different things that are all being connected with these 3 pipes. And now taking exactly what we have here and just adding on to it a little bit more, if we add on, we take that we just ran and then pipe that into this mutate, and we're going to tell it that we want mean plus SD to equal the mean MPG plus the SD MPG. And we want range equal to max MPG minus min MPG. And so note here, earlier I mentioned something about you can't have special characters and you can't have spaces and you can't lead with numbers in your variable names, but there's a way around that if you're using tibbles, not data frames. And that's with these marks right here. Now note this: these aren't the apostrophes; these are the back ticks that are up by the tilde. So instead of using shift to hit the tilde, if you just hit that button, it's these back ticks. So when you're using tibbles, you can have these special characters and leading numbers and things like that. Because if the whole thing is wrapped in those back ticks, then tibbles are able to recognize that, oh, this is a column name, that it's not M plus SD, but rather it's kind of analogous to recognizing it as characters, but it's not in quotation marks like this. Rather, it's in those backticks. But anyway, so again here, just showing like how these pipes can be used, that whatever comes out of it, you can pipe into the next thing, and we'll be working with that a lot over the course of this semester, and so you'll become real familiar with that. Sometimes with pipes, you need to explicitly call the left-hand side stuff into the right, and that's because or for a few different reasons. One could be that the pipes automatically pipe the left-hand side into the first argument of the right-hand side. So if you have x piped into function y, that becomes function x comma y. But if the default thing isn't quite in that order, you might have to have some other argument first, followed by the data. Or if you have nested functions. And so the way that you explicitly call piped data is by using a period. So if we have cars here and I just have this this function where I just want to concatenate the min and max, and I try to run this, it's not going to work. It doesn't recognize anything. But if I put these periods here, because this is a nested function, there's two functions, min and max, inside my overall function, which is denoted by these curly brackets. And so since I have functions within functions, I need to explicitly call. So if I add these periods, now these functions know, oh, I'm pull in this piped data. So when I run this, it didn't work because I changed that one thing to factor. So instead, let me call just the things that are numeric, and also including na.rm, because now I have some NAs in there. And so now we can see that the min value of all the numbers in the data is 0, and the maximum is 472. And then similarly, we can, let me go ahead and add back in my filter here just to get rid of things that aren't numeric. And then again, explicitly calling that, I just want to demonstrate that you can explicitly call the piped data with a period and then use that $sign to call that weight function specifically, and it will give us the minimum and maximum weight. Now, this particular thing is not a useful function. I'm just trying to demonstrate that sometimes if you're trying to do something with piping and it's not working, some functions, if they're not made for the tidyverse, might not play nicely or as nicely with piped data, and so you might need to use a period or even the period $sign, to get those functions to work. And you can always go to the help over here, and then you'll look at the forward pipe operator, and it will tell you about all these pipes. Just a couple more things. First, there's the apply family: apply, L apply, S apply, M apply. And the way that the only one we're going to talk about for now is L apply, which is list apply. And its basic setup is L apply, X function, other arguments. And when you run L apply, it applies whatever function you put in across, X, whatever X you put in. And it's L apply because it always returns a list. So if we put in cars as our X and we run L apply, I'm just going to reset our data frame so that we don't deal with those factors and crap that we were dealing with up there. So when you look at a data frame, this is actually, you could think of this conceptually as a list of lists, that you have one list that's the miles per gallon for each one, and one list that's the cylinders, and another list that's the displacement, and another list that's the horsepower, etc. So this is all a bunch of lists. So when you use lapply and you put in cars, in this case we're putting in mean as the function. So what that does is it tells it to go across this list, go across cars, and apply the function mean to this list of MPG, and to this list of CYL, and to this list. And so what it outputs is, here's the mean for this list, and here's the mean for this list, and here's the mean for this list. And so, if, for instance, we just wanted to select, our miles per gallon, and then displacement through weight, so these four things here, we can apply all those together. So if I just select this portion, that shows that we've now selected these 5 columns, and I can just pipe that straight into my lapply and apply the mean function. And now I get the mean for that column, that column, that column, that column, and that column. Real briefly, want to touch on user-defined functions, because this is something that's definitely useful to work on understanding. Because oftentimes one of the nice things about R is the flexibility, because when you can program your own helper functions, as we'll refer to them, you can get it to do a lot of different things. So real quick, there's a function called paste, and basically what paste does is, it takes the things that you put into it, the character strings that you put into it, and puts them all together as, one big character string. The default separator is a space, and that's why it took all these 3 different things that I put in, and it says how paste works with all these spaces in between. You can change that with sep equals. So if I change that to underscores, then it'll say, how underscore paste underscore works. If I change that to the @ symbol, it will put that in between. If I just put double quotation marks, then it will just it will pull them all together. Or instead of using this, you can just use paste 0, which is the same as this. That's the default separator, is to not put anything between, just to straight up butt up the words together. So let's just say that we wanted to make a function where we're pulling like, a mean and standard deviation, and we want the standard deviation to be in parentheses. So we can say function, and it's pretty typical to say function x, but we'll get to more of that in just a second. And then what we want is, the mean of x, and the standard deviation of x, but we need to paste these all together. So let's do paste 0, and then we'll have the mean, and then let's add in a space, an open parentheses, then the SD, and then a close parentheses, and then close up that paste. And now we'll store that function as something called MSD. So now if we run MSD cars MPG, it will output, the mean followed by the standard deviation. But those are ugly, so let's round those to 2 decimal points, and we'll round that one to 2 decimal points as well. Resave that function. Okay, now that's looking a little bit better. So the point here is that if you use, function something, and then you use these curly brackets, whatever is inside those curly brackets is the function. And then if you store that, that becomes this usable function. But it doesn't have to be function x, and it doesn't just have to be a single thing. For instance, I could just as easily create something, and that's going to be a function first, second, we'll call it. And we'll just say that the function is that you do first plus second. We'll just leave it at that. And now if we come down here and we say something, and if we put in 4, 8, it adds the first and second things together. So whatever you name things up here where you define function, like that's the names that you would use here within the brackets to call the specific things that you're using there. If I had 4 and 10 through 20, it's going to do that same arithmetic that it's going to take. It's going to take this 4 and it's going to put it into this function wherever that belongs, and whatever we put in for the second thing, it will put it in here. So it's going to add 4 to each of 10 through 20 and that sort of thing. So that'll definitely come in handy. We'll see more practical examples of this as we go through the semester, but being able to write simple functions like that is going to end up being really good for you, because when you can write your own simple functions and then combine that with the power of lapply, it can be a pretty great thing. Let's see if we do. So now just applying that MSD function that we wrote, putting it back up in this lapply, like we can output the mean and standard deviation formatted this specific way that we want it here. So a lot of that will come into play later down in the semester. But I'm now pushing an hour, so I'm really trying to wrap this up. I got one more thing to talk about, and that is transforming your data frames from wide format to long format. So let's say that you have a data frame and it looks like this. You have participant 1, there's 3 variables, variables 1, 2, and 3, and their values were A, B, and C. And participant 2, variables 1, 2, and 3 were D, E, and F, and for 3 it was G, H, and I. And instead, what you want is you want 3 rows for participant 1, where participant 1, variable 1, the value was A. For participant 1, variable 2, the value was B. And for participant 1, variable 3, the value was C, etc., etc. So how do you change from this wide format where you have 1 row per participant to this long format where instead you have 1 row per observation and we have 3 observations per participant? So instead I'm actually going to change that to 5 participants with 3 variables each, and I'm going to throw in a condition variable just to set up a simple data frame that looks something like you might see in an actual experiment. So here we have participants 1 through 5. They have 3 variables each, and they're either in the control condition or the experimental condition. And so the function that we're going to use from the tidyverse is pivot longer. Now pivot longer is a newer function. So the alternative to that is gather, which is basically the same thing, but they've changed some of the argument naming to make it a little bit easier for some people to understand it, but they do the same thing. So all you'll do is we're going to take now this data frame that we just created, and we're going to pipe it into pivot longer, and we're going to tell it that we want to collapse variable 1 through variable 3. We're going to change the names to variable XXX, and I'm doing this just to make it clear what all is happening and where things are going, and then values to numbers. And so when we run this line, you see it now, it transformed our thing into this long format. So now we have 3 rows per participant. Variable XXX, that names 2, that's where you're telling it, I want all of these 3 things in this column, and it's called variable XXX. And then Numbers is the actual values that were in those particular columns. Alternatively, instead of telling it like I want to collapse, variables 1 through variable 3, you could tell it, you could pipe in df and tell it with this negation here and concatenation to not gather participant and condition, because we want those to stay out on their own. But so that would return the exact same data frame. And then just because it's newer, if you're looking for help, you might not find as much, or you'll see people using gather instead on Stack Exchange or whatever the case may be. And so the only difference, like with this real simple example, is that instead of called names to and values to, it was called key and value, and the function itself was called gather instead of pivot longer. And so again, when you run that, it does the same thing. Well, that's enough time that I've taken up for today. So I will have some other a separate video that is specific to the functions that we're going to be using for the first unit in that first week of labs. And I may have a couple other things to point you towards to check out if you feel like you need any extra things. Again, feel free to let me know if you have any questions about anything that's said in all of this. And we'll talk to you later.